Okay guys, this week we're going to be looking at all the things that make up weather, all the different properties of weather and how that helps us to predict weather. So let's get started. Objective 22 is this is what we're doing. I can describe the different weather properties of fronts, air masses, pressure systems, clouds, and severe weather. So here's what we're going to go through: clouds, air masses, pressure systems, fronts, and storms. So we're going to start first with cloud formation. So you can see we've talked about the water cycle already, and so we know that the sun is the driving force behind the water cycle. So the first thing that happens is our sunlight warms the surface, and any water from the surface, well, not any, but some of it, will evaporate, okay? We know because of convection that as that warm air, or as that air gets warmed, and the water evaporates from liquid into a gas, that it's going to start to rise because we have convection currents, right? Warm air rises, cold air sinks. So that warm, moist layer builds up in the lowest 1,000 to 5,000 feet. Those are low clouds. And then your rising air currents organize into what you call thermals, and that's what push up. And then as that water vapor is getting pushed higher and higher into the sky, we know as you go up in the troposphere that temperatures decrease. So that's where step 4 comes in. Water vapor and rising air parcels condenses to form clouds because the temperature goes down and we reach our dew point. And when we reach our dew point, that's when condensation occurs. And when we have condensation occur, then we get the formation of our cloud. Okay, so we have evaporation of water. It rises due to convection currents. It gets into the upper atmosphere. The temperature drops, causing our dew point to be met, and then our water condenses. And as our water condenses around something called condensation nuclei, which is all those little particles in the air, as it condenses around those condensation nuclei, that's when our cloud begins to form. Okay, let's move on. Okay, so let's get into our types of clouds. We're going to start with the highest clouds, the ones that are highest in the sky. They're called cirrus clouds. They're thin, wispy clouds. You can see that they look like kind of like curls of hair. They're composed all of ice crystals. Remember, as we go up in the atmosphere, in the troposphere, as we go up, temperatures decrease. So our highest clouds at the top of our troposphere are made of ice because that's where it is coldest. Next we have cumulus clouds. They're also called like fair weather clouds. They're the ones we see most often, those white puffy clouds. They look like heaps of cotton. As long as they're nice and white, they're just like puffy. Those are fair weather clouds. They don't bring really any weather with them. And we see those on a nice day. Blue sky with nice white clouds in there. Those are cumulus clouds. The next type of clouds are stratus clouds. These clouds are flat appearing. They look like layers of blankets on top of each other. They appear low in the sky. And stratus clouds on the ground are called fog. Okay? But when it's an overcast day and the entire sky is covered, it is a stratus cloud that's covering the entire sky like a big blanket. Okay, so next we have the word part nimbus. Nimbus is not an actual type of cloud. It is part of a cloud. The word nimbus right here means rain producing, right here. That's when you see clouds that are gray in color. So you can have nimbostratus clouds, which is just like a steady rain, or you can have cumulonimbus clouds, which can bring us rain, but also bring us storms. Those are our storm clouds. So nimbus can either go it's a root word, and it can either go at the beginning or the end. So nimbostratus, where that one's at the front, meaning stratus clouds that bring rain, and then cumulonimbus, meaning cumulus clouds that bring rain. So the word part nimbus means rain producing. The word alto means high or high in the sky. Alto means high. So again, that is a word part when combined with other words, gives us an idea of where the clouds are in the sky. So we can have alto cumulus or alto stratus. So alto cumulus, so cumulus clouds are mid-level clouds. So alto cumulus clouds, these are alto cumulus right here. You can see how they're not as big and puffy as the white ones we saw earlier. They're smaller puffs, and they're located higher in the sky. And then again, you have alto stratus, which are a little bit higher in the sky. Stratus clouds are low-level clouds, so they're going to be at a little bit above low level, between low level and mid-level. And it just indicates their location in the sky. Okay, so here's an easy cloud classification. This is on your video notes that you're filling out. And I'm just going to circle the ones that you have to know for 7th grade. So you need to know cumulus, you need to know fog, you need to know stratus, you need to know cirrus, and you need to know cumulonimbus. And that's it. Those are the ones that you have to know. And you might need to know nimbostratus. That's it. Those are the ones you have to know for 7th grade, but these are all the different types of clouds that you can see in the sky. So moving on from clouds, going into air masses, fronts, and pressure systems, we're going to start with air masses. So this gets a little bit confusing for some people, but it's super easy. So there's 4 words that you need to know. The 4 words are polar, tropical, maritime, and continental. So polar, we think of like polar bears. Polar bears live where it's cold. So if you hear polar describing an air mass, it means that air mass is cold. Okay? So let me break out my mad drawing skills. This is a polar bear. I know you can tell. I'm going to color him white. There we go, little polar bear. Okay, polar means cold. He looks kind of like a skeleton. I should probably color that in. Alright, polar means cold. The next one we're going to get to is tropical. Okay, and wow, this is a really bad bear. Whatever, you guys know. It's awesome. Alright, tropical means warm. We all like to be in tropical locations, right? Okay, so here's my little palm tree indicating that tropical is nice and warm. Put some little coconuts on there. Amazing. Okay, maritime is actually a Navy term. And maritime, because it's a Navy term, and the Navy controls the water or the sea. Remember, the military covers land, air, and sea. Navy is in charge of the sea. And because the Navy's in charge of the sea, maritime means that the air mass is wet and it's bringing a lot of rain with it. Okay? And then, of course, we have continental, and you guys know that continental means continent, which is made of land. So if an air mass forms over the land, it's not going to be wet, it's going to be dry. Okay? So those are the 4 things that you need to know, and then we can put them together. So let's talk about that next. So a maritime polar, maritime meaning water, polar meaning cold. Let me get a different color other than that ugly brown. So maritime meaning wet, polar meaning cold. So this maritime polar air mass is both wet and cold. You can see that it forms up here in the north. If this is the United States, it's forming over the water in the north. Okay, so we know the further away we get from the equator, the colder it is. So this is where maritime polar air masses are going to form. Okay, next one is maritime tropical. So maritime, again, maritime meaning wet, tropical meaning warm. So this is going to form over water because it's wet, and tropical where it's warm. So now here's our maritime tropical air masses. This is where they form over the water by the equator. Okay? Moving on, we have continental polar. So continent meaning dry, polar meaning cold. Okay, so this air mass is forming over the land where it's cold. So you can see it's from the north, or it's in the north, and it's forming over land. And so this is where the continental polar air masses form, and this is where it goes down here, especially in the wintertime, to come get us, and we get those nasty ice storms. And we have one more. Ooh, I lost my card. Okay, the last one is continental tropical. So continental tropical, so continental meaning dry, because it forms over the land. Tropical meaning warm, so this air mass is going to form where it's dry and warm, so near the equator, over land, and this is where this air mass heads. Okay, so those are the 4 different types. So you got to remember, maritime means wet, continental means dry, and then you have polar, polar bear, cold, tropical, our nice little palm tree that I drew, meaning warm. So if you remember those 4 words, then you can put them together. And it always comes whether the moisture first, whether it's wet or dry, and then the temperature, whether warm or cold. So you're either going to have continental or maritime first, then tropical or polar second. Okay? And you can never have a polar tropical air mass. That doesn't make sense. It can't be both warm and cold at the same time. It's one or the other. Okay? All right, moving on. All right, so here are, and this picture I'm pretty sure is in your video notes. Here is what I just went through with you, where all of your different air masses form. Okay, the other one that we didn't go over is an Arctic air mass, which is just, it's colder than the polar air mass, but don't worry about that. These are the ones that you need to know. All right, moving on to fronts. So a front, it's called a front because it comes in front. Someone who's at the front of the line leads the line. So a front leads an air mass, okay? So if, we're going to talk about this in a second. There's 4 different types. We have cold fronts, warm fronts, stationary fronts, and occluded fronts. Let's first talk about a cold front. Okay, again, it's called a cold front. Whoa. Okay, it's called a cold front because this cold front is at the front of a cold air mass. So this is cold air. This is the front of the cold air mass. It is separating us from the warm air ahead of it. Okay, so again, it's called a cold front because it's the front of the this cold air mass right here. Meaning there's cold air behind it. And if there's cold air behind it, it means that there has to be something different in front of us. So warm air in front. So cold fronts are going to, because they are more dense, wedge their way underneath a warm air mass and push the warm air mass upward. Okay? Let me get out a drawing so I can show you this. Okay, so here we are again. This is still your cold front. This symbol down here, this blue with the triangles on it, they look like icicles, and I'm going to remind you that a cold front is icicles because it's cold and it's blue, just like the blue, it has a blue C on your shower or your faucet at home because blue is for cold. So your symbol is blue, and it has little triangles on it, which we're going to call icicles to remind us that that's a cold front. Again, cold fronts go in and wedge underneath and push the warm air up above them because cold air is more dense than warm. Okay, let's go on to warm fronts. Okay, so same thing. It's called a warm front because it is the beginning of a warm air mass. So here's the front right here. Here's the warm air behind it and cold air in front of it. The warm air is going to go up and over your cold air mass because your warm air is less dense. And we know that. Warm air is less dense. Warm air masses typically move much slower. And when we get a warm air mass, we are going to get some like rainy or cloudy weather for a couple days. And then after that passes, we're going to have humid and warm air coming through. Okay, then we have something called a stationary front. If something is stationary, like a stationary bike, that means that it doesn't move. So same thing with a stationary front. Stationary fronts don't move. And what I forgot to tell you in the last one, if we go back just a second, we talk about warm fronts. That symbol is blue, and it's red. I'm using purple here, so let me not confuse you. A warm front is red, just like warm or hot water is red. And it's like half circles, and we're going to call those like little half suns. So we remember that a warm front is little half suns. So that helps us when we get now to a stationary front. So here's the symbol for a stationary front. And it's when a cold air mass and a warm air mass meets, but neither one moves. Like the cold air mass doesn't push underneath the warm doesn't go above the cold. They just meet and they just sit there. So you can see that the cold air mass is moving this way because that's the direction that the triangles are moving. And your warm air mass is moving this way because that's the direction of these half circles or half suns. And it just sits there. And what happens is we just have precipitation for several days until one air mass finally overtakes the other. Okay, so that's a stationary front. And if you remember that a stationary front is like a stationary bike. Let me get my mad drawing skills out now. Here's my bicycle. It's a stationary bike. The bike doesn't move. You get on it like for exercise at the gym. You get on one of those bikes and you pedal, and you never leave. Your wheels spin, but you don't go anywhere. It's called a stationary bike because the bike actually doesn't move. Same thing with your stationary front. It doesn't move. All right, one more is called an occluded front. This one's, I don't know why we have issues with it every year. I'll try to explain it better than I have in years past. So what has happened is because warm air masses move slow, so warm equals slow, and cold fronts move fast, what happens is you have a cold front here, and you had a warm front. So remember I told you warm fronts move up and over cold fronts? And then you have another cold front back here. And so this first cold front right here, here's number 1, here's number 2 cold front. This second cold front has moved in to overtake and cut off this warm air mass right here from the ground. So now you have these two cold air masses converging. So if something is occluded, it means that it's cut off. So what happened is that the warm air mass was cut off from the ground because another fast-moving cold air mass came in. Okay, so that's what it says down here. 2 cold air masses cut off and lift up a warm air mass. Here's your warm air mass here. Here's your cold air mass number 1, cold air mass number 2. We get cloud formation and possible precipitation. Something that I want to tell you guys, if you see the word front, it equals bad weather every single time. Cold fronts bring us thunderstorms. Thunder. Okay. But if you see that it's a warm front or a cold front or a stationary front or an occluded front, they always bring bad weather because it is the front of a new air mass, and whatever's in front of it is different from what was there. So if you have a warm air and cold air meet, we're going to get cloud formation because some of those air molecules are going to reach their dew point, and we're going to have cloud formation, and we're going to get precipitation because of that. So a front is the beginning of a new air mass. It's the beginning. It's what separates a cold air mass from a warm air mass. And where that front is, we always have clouds. We always have bad weather. And cold fronts, because they're fast moving, they bring us thunderstorms. Warm fronts are just going to bring us steady rain. Same thing with an occluded front and a stationary front. Just rain for a few days. Cold fronts are associated with bad weather. Okay? All right. Moving on. We're going to get now into pressure systems, high pressure and low pressure. So cyclones are also called low pressure. Low pressure is always associated with bad weather. So we know from watching our hurricane that a low pressure system brings us bad weather. It is a swirling center of low pressure. Clouds, wind, and precipitation form, and they form at frontal boundaries. So that's what we were just talking about. They form at fronts. So low pressure equals bad weather. Every time you have a front, there's going to be a low pressure system there. Okay? Low pressure systems move counterclockwise and up. They are rising air. You can't have cloud formation with sinking air. You have cloud formation with rising air because warm air rises, cold air sinks. So with a low pressure system, it is moving counterclockwise, just like we looked at with our hurricanes, and we have a rising air, and that rising air is cooling, and we're getting cloud formation, and cloud formation brings us bad weather. Okay, so cyclones, also known as low pressure systems, we're probably going to refer to them always as low pressure, but you need to know that cyclone is also the same thing as low pressure. Okay? Low pressure brings bad weather. When you feel low, you feel bad. Low pressure, bad weather. On the opposite, we have an anticyclone. They're high pressure centers of dry air. In this one, you see that the air is moving down. So your weather is going to be a little bit cooler than the surrounding air. They also, your high pressure system, if you're feeling high on life, you feel great. So high pressure systems bring us good weather. Yay. Okay, and they are going to move clockwise and downward. You see this is sinking air. And if we have sinking air, we don't have cloud formation with sinking air. Okay? Moving on. So this is just, again, summing up what I just told you, and this is what's on your video notes. So high pressure systems, anticyclones, bring us calm, clear weather, where low pressure or a cyclone where you have hot air rising brings us stormy, cloudy weather. No cloud formations with a high pressure system, lots of clouds with a low pressure system. Okay? And the last thing we need to talk about is severe weather. So let's jump right in. Floods. So flooding, you guys probably just experienced this with the hurricane Matthew that just came through. So it's when we have a volume of water increasing in a short period of time, causing a body of water to overflow its channel, like a river or a stream to overflow its banks. A flash flood happens really fast, meaning there was nothing there before and now it's happening really fast. Usually, things like dams and levees are all safety measures and forms of flood control, but when you have a lot of rainfall in a short amount of time, like we did with Hurricane Matthew, you have overflowing and you get flash floods happening really fast, which is why people get stranded in their cars and have to be water rescued because it happens without warning. Droughts are the opposite of floods. So droughts is when we don't get water for a long period of time. You can have no to little amounts of rainfall. It's caused by dry weather systems that just remain in place for a long, long time. And when we have a drought, and you guys may have been through this, where they tell you not to water your lawn and to take shorter showers and to try to conserve water because of a drought. Okay, thunderstorms we're most familiar with. We talked about cumulonimbus clouds already. That's where our thunderstorms form. They form when warm air is forced up rapidly along a cold front. And I told you cold fronts bring us thunderstorms. That's good to know. Characteristics of a thunderstorm: heavy rain, possible hail, strong upward and downward winds, your updrafts and downdrafts. And the updrafts are what make those huge cumulonimbus clouds. Remember we talked about how some cumulonimbus clouds reach into the stratosphere. And that's how, because you have strong updrafts that go up and sweep those clouds. That's how they get really, 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 really tall. And they're called thunderheads because they get really, really tall. Those are your cumulonimbus clouds. And obviously we have thunder and lightning with a thunderstorm. We're almost done. Tornadoes. Tornadoes develop in thick cumulonimbus clouds. They form when a warm, humid air mass meets a dry, cold air mass. So we're talking opposite types. Warm, humid meets dry, cold. Warm air is forced upwards along a cold front to produce several thunderstorms, which then can turn into tornadoes. They're the most damaging type of storm because they're not predictable. Okay? And then Tornado Alley, I think somebody asked about that a week or so ago. It is in central U.S. from Texas to Nebraska and Iowa. Nearly 800 tornadoes form in that area every year. And I'm going to go back and show you that in just 1 second. Okay, so I want you guys to take a look at this. As you can see, here is our, it's when we have these air masses, these warm, humid air masses meet this dry, cold air mass. And so here's central U.S. where those tornadoes meet Tornado Alley, and it's because these maritime tropical air masses are meeting this continental polar air mass. And that's where they meet most often, and that's why we get tornadoes in that area called Tornado Alley. And last but not least, we all know about hurricanes because we've been looking at them for the last couple weeks. Here are their characteristics. They have to have winds over 119 kilometers per hour. They are at least 600 kilometers across. They form in the Atlantic, Pacific, or Indian Oceans. The strength of them comes from the warm, moist air. And we talked about that especially with climate change. If our oceans are warming up, our hurricanes are going to continue to gain strength even as they move further north instead of dying down. Because a hurricane is bad weather, they're going to form over low pressure. You can see that in this picture that it's moving counterclockwise. And we talked about that already. Hurricanes form over warm ocean water as a low pressure area. As the area grows in size and strength, it's going to be a tropical storm first. And we talked about how it can be upgraded or downgraded when we were going through this, followed by a hurricane if it continues to grow. And we had Hurricane Matthew come through as a Category 4 when it hit Haiti and Cuba. And then as it came up to Florida, it was like a Category 3. And as it moved up the coast towards North Carolina, when it hit us on this past Saturday, it was downgraded to a tropical storm. So the higher the category, the bigger the storm is. Category 1 is the smallest hurricane, but still has to meet these criteria to be called a hurricane in the first place. Otherwise, it's a tropical storm. And last but not least, we have 4 types of precipitation. All year round in all areas of the world, most precipitation begins in clouds as snow and melts when it reaches warmer temperatures. Precipitation will remain as snow if the air temperature is colder than 0 degrees Celsius. And we have 4 types: rain, snow, sleet, and hail. Okay, that's it for this week. I'm sorry that they're long. I will see you guys in class. Bring any questions you might have with you so we can discuss it when we go over our notes. Have a great day.